Hi, this is the Neuron animation project for Miss Adams' first period class by Adam Alarabawi, Eli Morris, and Derek Yao.
First, a brief overview of neuron structure. A stimulus is received in the presynaptic cell by the dendrites of the neuron. It then travels through the axon hillock and the axon where it reaches the synapse. At this point, the signal is transferred via a chemical called a neurotransmitter to the postsynaptic cell.
The sodium-potassium pump helps maintain resting potential with more potassium inside and sodium outside of the membrane against the electric/concentration gradient and a net removal of positive ions. The net movement of positive ions out of the membrane via the ungated ion channels, meaning that they move with the gradient, helps to establish a highly negative potential. Then the membrane goes through the depolarization phase where the sodium channels open and the sodium flowing in causes depolarization, which is a net increase in membrane potential. An action potential happens when the threshold of potential is reached. The process continues and proliferates in the rising phase with the potassium channels staying closed. In the falling phase, however, the situation reverses with the sodium channels blocked and potassium channels open for potassium to flow out for repolarization. In the undershoot, the potassium channels start to close and sodium channels open a bit to return to the resting state. Action potentials move as sodium flows out at one spot, followed by depolarization by potassium in that same exact spot. The repetition keeps occurring and moving throughout the axon linearly until a synapse is reached. The action potential arrives at the synapse and depolarizes it, causing calcium channels to open and let calcium in, which elicits the fusion of synaptic vesicles to the presynaptic membrane. This causes the neurotransmitters to be dispersed into the synaptic cleft where they can bind to the ion channels that allow sodium in and potassium out to continue the cycle.
Sarin gas is a highly toxic nerve agent, causing immediate lethal damage unless an antidote is quickly provided, initially developed as a chemical weapon by the Germans in World War II. It functions by inhibiting acetylcholinesterase, which breaks down acetylcholine. As depicted, acetylcholine is a common neurotransmitter that is essential in activating the sodium channels in the postsynaptic cell. Acetylcholinesterase essentially stops the transmission of the signal. Therefore, serine essentially maintains the signal for much longer than it should be activated, with the sodium channels continuing to induce depolarization. It specifically targets the acetylcholinesterase